everybody. Mr. Covey here, and today we're going to talk about something kind of related to probability, but not really. Okay, so it's kind of like we talked about probability, and now we're talking about another thing. It's a little bit different. And what we're really going to talk about is something called counting. Okay, and I know you're like, I know how to count. I know. But what it is ways to count the number of possibilities of something. So we're going to have a scenario, and I'm going to say, hey, you're going to pick this and that and that. How many different possible ways could you do that? How many possibilities are there? How would you count all of those possibilities? And we're not going to count them by like listing them all out, because this is where there's going to be a lot of possibilities, these scenarios. So instead, I'm going to show you 3 ways to count the number of possibilities. Okay, so what we're doing is counting possibilities using 3 different tricks. Okay, these 3 different tricks, the hard part about this is going to be deciding which one to use. Okay, so I'm going to show you one example with each of these 3 counting techniques, and then we're going to try and kind of like say like, okay, what's the difference in these situations? How do you tell which of these 3 techniques to use? Okay, so this first situation, okay, you got 12 pairs of pants. You got 3 different shirts. And then you got a pair of running shoes and a pair of sandals. So you got 2 different pairs of shoes. The question is, how many different outfits are possible? How many different possible outfits are there? Okay, so you just think about this for a second. You think about your 12 pairs of pants. Maybe you have like, you should do some drawing. Maybe you got your red pair of pants. That's a good pair of pants. Your green pair of pants. You got your blue pair of pants. You got your pink pair of pants. You got 12 pairs of pants. 3 different shirts. You got a red shirt. You guys get the idea. Blue shirt, a green shirt, and 2 pairs of shoes. And you want to see how many possibilities there are. Well, there's a lot. You could wear your red pants with your blue shirt and the running shoes. You could wear the red pants with the red shirt and the sandals. You could wear the green pants with there's a lot of different possibilities here. So to count all these different possibilities, we're not going to list them all out. We're going to use a technique called slots. Okay? And for this technique, we're going to think about the fact that you're really making 3 different decisions in this problem. And I'm going to draw a slot for each different decision. So what's one thing you're picking? You're picking a pair of pants. What's another thing you're picking? You're picking a shirt. What's a third thing you're picking? You're picking a pair of shoes. And then on the slots themselves, I'm going to list the number of choices for that single decision. So when I'm thinking about picking a pair of pants, I have 12 choices. When I'm thinking about picking a shirt, I have 3 choices. And when I'm thinking about picking shoes, there's 2 different choices. Once I have these slots laid out like this, I am going to multiply them all together. So I'm going to do 12 times 3 times 2. I'm going to get 72. And there is 72 different outfits. Okay, that technique is called slots. Again, we'll talk about when you use this technique in a minute here. Second scenario. There are 42 cars in the Indianapolis 500. How many first and second place possibilities are there? Okay. So, again, there's 42 cars, so you could think about them as, if you want to think about them as numbered, there's car number 1, car number 2, car number 3, car number 4, car number 5. They're asking you how many different first and second place possibilities are there. So it could be like car 31 gets first and car 7 gets second. Or car 33 could get first and car 6 could get second. Or car 9 could get first and car 17. There's a lot of possibilities here. To calculate this, we're going to use a fancy thing on your calculator. Okay, so grab out your graphing calculator, and I'll grab mine out, and I'll show you how this works. Okay. So the first thing you're going to put, I'm going to write down the notation here, and then we'll put it in the calculator. First thing you're going to put is the number of things you're choosing out of. Choosing 42. Then you're going to put a P. P is for permutation. And we'll talk about what that means in a second. After that, you're going to put the number of places that you're choosing. So we're taking the 42 cars, and we're asking how many possible ways are there to choose 2 of them. Okay. Type that in your calculator, you do this. Watch. First type 42. Then you hit math. and you go over to that PRB. And that PRB stands for probability, because this is related kind of to probability. You go down to the NPR, and you see it kind of looks like our something P something, NP something, NPR. Here's our N, here's our P, here's our R. So we click the 42. We're going to, oops, sorry. We clicked our 42. And now we're going to go down to NPR and click that. And then after it, we're going to put 2. And it's going to tell us how many possibilities there are. 1,722 possibilities. Okay? We'd never be able to count all those if we could. It'd just take all day. But we use this P, this permutation trick, to help us. Okay? Third situation. It says, how many different ways can you select 3 people to invite to your birthday party out of your group of 15 friends? Okay, so you got 15 friends. You got Mike and Sarah and Isaac, and Maura, Grace. You have 15 friends. And you want to select 3 of them to come to your birthday party. So you want to pick Isaac, Maura, and Mike. Or you could pick Grace and Sean. There's all these different possibilities. Again, we're not going to list them all out. We're going to do something similar to what we did up here in this example, only there's going to be one little difference. So it's going to look very similar. We're taking 15 people, and out of those 15 people, we're selecting 3 of them. Only instead of using a permutation here, we're going to use a combination. We're going to use a C. Again, we'll talk in a second if you can see the difference between these scenarios, these 2 scenarios here. There's a difference, and there's a reason, therefore, that we use the C instead of the P. Okay? But when you type this in your calculator, it's a very similar process. You do 15 total people, go to math, go over to probability. This time, not NPR, NCR. Click enter. Out of those 15 people, you're choosing, sorry, let me get my thing done. Out of those 15 people, you're choosing 2 of them. And here there's 105 different possibilities. Okay, 105 different groups of 3 people you could choose out of your 15 friends. Okay. So if you look at these 3 different strategies, you can kind of see some differences. So I want you to take a second, read back over these scenarios, and see if you could identify some differences. Okay, so the first problem is very different than the other 2. I think the thing that, in my mind, separates the first problem is that you're making a lot of different decisions. There's a lot of different things you're thinking about, okay? You're choosing a pair of pants, you're choosing a shirt, and you're choosing a pair of running shoes. In the other 2, you're just choosing, like, out of the same group. Like, you're choosing 2 cars, but they're just out of the cars. You're selecting 3 people, but it's just out of the group of people. There's not these separate, different decisions, okay? So when I think about that slot strategy, I use it when you're making multiple different decisions that are, like, unrelated to each other. So, like, you're choosing a pair of pants, you're choosing a pair of shoes, and you're choosing a shirt, and those things are like different decisions. They're unrelated to each other. Okay. When you use this technique, remember that the number of slots is the number of decisions. So there was 3 slots here because you were choosing a pants, a shirt, and shoes. Okay. And you put in the slot the number of options for that choice. Okay. So there was 12 pairs of pants, 3 shirts, 2 shoes. So you put in the slot the number of options for that choice, and then you multiply them all together. Okay, and that's how that slots technique works. That one's not too bad. Oops, sorry. If you look at these last 2, they're very similar. You got a group of 42 cars, you're picking 2 of them. You got a group of 15 friends, you're picking 3 of them. What's the difference between them that causes, like, this one use a P and this one use a C? It has to do with whether the order matters. So in the Indianapolis 500 one, when you count 31 and 7, like car 31 finishing first and car 7 finishing second, that's one possibility. But car 7 finishing first and car 31 finishing second counts as a different possibility, right? Because if you're racing, first is different than second. Okay, so the order that you pick the two numbers, you can't just say, yeah, car 37 or car 31 and car 7. The person's going to be like, which one got first? So when the order that you pick the things in matters, you need to use a permutation. Okay? And that's what you'll hear people say. Use a P, a permutation, when the order that you're selecting the things in matters. If you look at that third example, when you're picking that group of 3 friends to come to your birthday party, there isn't an order. Like, picking Mike, Moore, and Grace is the same as picking Grace, Mike, and Moore is the same as picking Moore, Mike, and Grace. You're still choosing the same 3 people. It doesn't matter the order. Okay? When the order doesn't matter, it's called a combination. Okay, and that's when you use the C. So you use the C when the order doesn't matter. Both of these things have the same format. Whether you use a C or a P just depends on the order. Here you put the total number, and here you put the number you're choosing. Sorry, it's really sloppy. Okay, and it always works like that, and they're right next to each other on the calculator too. If we had more time, I would show you how exactly your calculator is doing that calculation. Like what are they doing with those numbers? They're using something called factorials. And it's cool, but we just unfortunately don't have time with the remote learning stuff. Okay, but don't worry, you'll learn about it in another class. Okay, so then what I want to do for the rest of this video is, last year in my AAA class, we had more time again because we were in person. So I had some students, as one of their things, write their own permutation, combination, and slots problems. Okay, and I'd like you to go through these 12 problems. There is the answers at the end. Okay, and I'm going to do a few of them with you. Okay, cool. Let's start with number 1. We'll do number 1 together, and then we'll do 2 other ones together. Okay, so it says, hey, at the Ponce team's first dance competition, there was 200 teams competing. The awards are given to first place, second place, and third place. How many different ways can teams win? Okay. If you go through our possibilities of slots, permutations, or combinations, it's not slots. We're not like picking a dance team and picking a football team. There's not like different things going on. We're just picking the first 3 in dance teams. And because there's a first place, a second place, and a third place, the order matters, right? Like, you don't want to be second, you want to be first. The order that you get picked in matters. Therefore, we're going to use the P. How are we going to use the P? We're going to use it by putting the total number you're choosing out of in front, and after it, the number that you're picking. We're just picking first place, second place, and third place, so we're choosing the first 3 places out of a total of 200. Grab your calculator, gotta type the 200 in first, hit math, go over to probability, NPR, boom, we're choosing the first 3, bam. There is 7,880,400 different possibilities. That's a lot of possibilities. But if you think about it, it could be like the team from Ohio and the team from Iowa and the team from Florida. Or it could be the team from Florida that gets first and the team from Louisiana that gets it. There's just a lot. There's 7 million possibilities. Okay. Cool. Let's do question 5. Okay. Mr. Covey wants to decorate his calculator. Seems likely. He has 7 different stickers, 5 different washi tapes, and 8 different glitter colors. How many different designs can he make? Okay. So if you're thinking about this one, I'm thinking I got to pick a sticker, a washi tape, and a glitter color. Those are like multiple decisions, different decisions that don't have anything to do with each other. That's exactly when you should use slots. Okay, I'm picking a sticker, I'm picking a washi tape, and I'm picking a glitter color. Making 3 different decisions, a slot for each decision. For the sticker decision, there's 7 possibilities. For the washi tape decision, there's 5. For the glitter decision, there's 8. Multiply those all together, boom, bam, boom. Type in your calculator, 280 different possibilities. Okay, cool. Okay. And I want to do question 2 together, okay? So it says, Boy Scout Troop 122 is having their biannual leadership position elections this May. No singular troop member can serve in more than one leadership position at a time. With 43 qualified and active troop members, in how many ways can they fill the main positions of senior patrol leader, assistant senior patrol leader, scribe, webmaster, and quartermaster? Okay? All right, so if you're thinking about this, this is a little bit confusing one. That's why I wanted to do this one. You got 43 people, and you're choosing from those same people. So it's not going to be slots. I know what you're thinking. Like, there's different positions. That's true, but you're still choosing from the same people the whole time. So this is not going to be slots. So then you're probably thinking, okay, well, does the order matter? Well, there's not really a first or second place. So it doesn't really seem like the order matters. Except the order does matter. Here's why the order matters. If I just tell you 5 people that got these 5 positions, if I was just like Maura and Cam and Meg and Grace and Sophie got the 5 positions, that wouldn't actually answer the question, because your first question would be like, well, who does what position, right? So the order matters in the sense that the positions are different. Okay, so you'd have to say one possibility would be Sophie senior patrol leader, Grace assistant senior patrol leader, Cam. But then if it was Grace senior patrol leader and Sophie assistant, that would be a different possibility. So because those positions are different, the order that you pick the people in matters, because you'd be assigning them different positions. So because the order matters, we need to use a permutation. So we have 43 people. And from that, we're choosing people to fill 5 positions. Again, we're using a P because the order matters. Okay. 43, NPR, 5. That's a lot of possibilities. 115 million. 511,000. 760 possibilities. It's kind of like my bank account. That's a lot of possibilities. And why are there so many possibilities? Because there's all these different positions that you're filling, and anytime you like switch one of them, it would change everything. Okay. I would like you to try and do the rest of these problems. It's going to be kind of hard. The good thing is on Tuesday we're just going to practice this more. So go ahead and give it a try. The answers are at the end. Keep that in mind. And that concludes this video. Thanks for watching, guys.